Chapter 10 Numerical Methods Lesson 1 Locating Roots. As you might know, a root of the function f of x is the value of x where f of x is equal to 0. The graph y equals f of x will cross the x-axis at the roots of the function. Sometimes you can show that a root exists in an interval a, b if there's a change in sign where it goes from positive to negative or vice versa within the interval. If a function f of x is continuous on the interval a, b, meaning that it doesn't jump from one value to another, all x values within the interval have a valid output, and f of a and f of b have opposite signs, so either from negative to positive or the other way around, then f of x has at least one root, x, where a is less than x, which is less than b. Let's do some examples. The diagram shows the graph y equals f of x, where f of x is x cubed minus 4x squared plus 3x plus 1. Part A. Explain how the graph shows that there is a root for f of x between x is equal to 2 and x is equal to 3. And Part B. Show that f of x has a root between x is equal to 1.4 and x is equal to 1.5. For Part A, the graph crosses the x-axis between x is equal to 2 and x is equal to 3. This means that there is a root of f of x between x is 2 and x is 3. For Part B, if we find f of 1.4 by plugging x is equal to 1.4 in this, we get f of 1.4 is 0.104. If we do the same for f of 1.5, we get negative 0.125. As there's a change in sign between x is equal to 1.4 and x is equal to 1.5, and f of x is continuous on the interval 1.4, 1.5, that means that there's at least one root between x is equal to 1.4 and x is equal to 1.5. There are three situations that you have to watch out for when using the change of sign rule to find the roots. A change in sign doesn't always mean that there's exactly one root in the interval, and no change in sign doesn't always mean that a root doesn't exist in the interval. For the first situation, there is a change of sign between x is equal to a and x is equal to b. However, there isn't just one root. There are multiple roots on the interval ab. In this case, there will be an odd number of roots. For the second situation, there is no sign change when x is equal to a and x is equal to b. However, there are multiple roots. In this case, that means that there will be an even number of roots. For the third situation, the function isn't continuous on the interval ab. There is a vertical asymptote, so although a sign change may happen, there is no root. Let's do one more example. The graph shows y equals f of x, which is 54x cubed minus 225x squared plus 309x minus 140. A student sees that both f of 1.1 and f of 1.6 are negative, and so states that there are no roots in the interval 1.1, 1.6. Part A. Explain from the diagram why the student is wrong, and then Part B. Find f of 1.3 and f of 1.5 and use them to explain why there are at least three roots in the interval 1.1 is less than x, which is less than 1.7. For Part A, the diagram shows that there could be two roots in the interval 1.1 and 1.6, and so the student is wrong in saying that there could be no roots. For Part B, if we find f of 1.3 and f of 1.5, but on top of that we find f of 1.1 and 1.7, we get f of 1.1 is negative 0.476, which is less than 0, f of 1.3 is 0.088, which is bigger than 0, f of 1.5 is negative 0.5, which is less than 0, and f of 1.7 is 0.352, which is bigger than 0. F of x is continuous from 1.1 to 1.3, 1.3 to 1.5, and 1.5 to 1.7, and there's a change in sign in all three of the intervals. This means that there are at least three roots in the interval 1.1 is less than x is less than 1.7 as required. And that's about it.